So we're going to wrap up our discussions with some thoughts about usage considerations when you apply or think about applying atomic classes and operations in Java. So you should generally be careful in using atomic operations, and that's because they busy wait. And as we talked about before, if there's low contention, not a problem. If there's a lot of contention, then they'll spend a lot of time spinning, which is what we're showing here. Busy waiting can needlessly waste CPU cycles when there's high contention. If you have lots of threads that are all converging on a shared object, like a synchronizer, like an atomic long, then you're going to have problems. However, some spinning is actually quite useful and intentional in modern multi-core processors, where putting a core to sleep and waking it up is an incredibly expensive operation relative to other things. And so again, if you want to learn more about the techniques that are relevant here, take a look at this talk by my friend and colleague Doug Lee, where he talks about why some spinning is a good idea in multi-core processors. And the reason why this is important is that suspending and resuming cores is expensive. And there's a fair amount of overhead to put them to sleep and wake them up again. So if they are capable of running and doing something useful, you would much rather have them do a little bit of spinning if they can do something useful very quickly. Of course, if they spin for too long, then you need to put them to sleep. And that really comes down to what we talked about earlier when we were talking about adaptive spin locks. We also talked about the fact that these various Java atomic classes have so-called compare and set methods. And these provide a portable means to access the lower level compare and swap operations. So again, things like the unsafe compare and swap long or the Java var handle stuff, those would be examples of methods that get applied here. These types of methods are intended for very specific use cases. We saw an example here where we try to set the computed seed value atomically, which will only succeed if S is still the current seed value. And as you can see here, compare and set is only called once per loop per thread, and it only succeeds in one thread. So it's very localized, a little spinning, probably not a lot of spinning. So those are just a few things to keep in mind when you consider applying atomic classes and operations.